Hey y'all, Miss Hantla here. Just trying to get everything situated so I can, whoops. All right, here we go. So today's lesson, I'm gonna go over linear functions. Can I write on this? I cannot. Oh, I forgot I cannot write on this, so I gotta take pictures of it. We have been talking about equations and graphs and everything like that. And right now we are gonna go over this lesson, kind of piecing everything together. Is that the end of the first one? There's just some more room down there. Okay. So let me move myself again. Okay. Sorry. Linear functions. So a linear function, of course, is linear. It's a straight line. If it goes to the origin, it's proportional, but it can be linear and not be proportional. A function, we've talked about relations and functions. So a function is when every single domain is mapped to its own range. You don't have two domains going to, or the same domain going to two ranges. It's kind of like we've talked about if students are your domain, you can't have one student making an A in social studies and that same student making a D in social studies. If the student makes an A in social studies, it makes an A in social studies. Other students can also make an A, and that's perfectly fine. That's a function. We've talked about the vertical line test and other things surrounding functions. So now we're going to go into real world problems, but just a quick review. The domain is the set of x coordinates. It's also the input, and it's the independent variable. Whoops, variable. Oh, okay, let me move it some more. Variable. So those are all the words to describe the domain. The range, as a review, the range are the x coordinates. It's the output, and it's the dependent variable. The y depends on the x. And slope-intercept form, we've learned, is y equals mx plus b, where the m is the slope and the b is the y-intercept. It's that initial value. Initial value. Now, sometimes you might see the equations written with the b first, but I'm going to just put them in regular slope-intercept form to at least be consistent. So let's go to our first example. The farmer's market sells apples for $2 per pound and oranges for $1 per pound. Marjorie has $10 to spend, so that's the most that she can spend. Here's a function, y equals, and again, that's kind of written backwards, y equals 10 minus 2x. And the reason this one's written backwards is because it's starting with her money, $10, and every time she buys apples, then it takes away from her money. It represents the number of apples, X, and oranges, Y, when really it represents the number of pounds of apples and the number of pounds of oranges. Marjorie can purchase. Graph the function. So part one, we want to graph the function, and part two, interpret the point. So whenever you see that word interpret, we just think units. We just got to use units with it. So the first part is to graph. So y equals negative 2x plus 10. My slope is negative 2. My y-intercept is 10. Now, the y-intercept is the initial value. So before she buys anything, she has $10 to spend. That's why it's the initial value, because she has $10. Now I'm going to use my slope, negative 2 over 1. And if you notice the graph, they're counting by 2. So you have to be very careful. We're going to go down 2 over 1. So I'm kind of in between. If you wanted to, since these are counting by 2s, you could say negative 4 over 2. It's the same, it's equal. It just might help us count, go down 4 over 2, and then we'd be at the next square. But if you want to go down 2 over 1, you're in the half, down 2 over 1, down 2 over 1. Now, because this is a real world problem, I'm not going to draw arrows. I'm not going to go into my negatives because you're not going to have negative money, but I have graphed it. Now, interpret the points graphed. I have a lot of points graphed, so I want you to interpret 3 of them. I want you to interpret 3. So let's just take this first one we did. To interpret it, that just means use units for what it means. And this means that Marjorie can buy 10. This is on the this is on the Y. So the Y was pounds of oranges. Okay, I'm going to write that on here. Pounds of oranges, pounds of apples. Ooh, that's very crooked. I'm so sorry. Pounds of apples. So Marjorie can buy 10 pounds of oranges and 0 pounds of apples. 10 pounds of oranges and 0 pounds of apples. Now the next point I'm going to do is this one right here, just because it's like nice and neat on the graph. And this point is 2, 6. So we can go in that order too. Marjorie can buy 2 pounds of apples and 6 pounds of oranges. And then we need to do one more point. So I'm just going to do this one right here. And this point is 4, 2, which means Marjorie can buy 4 pounds of apples and 2 pounds of oranges. So that's what it means by interpret. Just like we interpreted the intercepts, when you interpret, you take what that ordered pair is, and then you write what it actually means. All right, so there's an example for you. I've got to take a picture of the next one. Oh, so simple. Y'all gonna be like, Miss Hantla, really? It is in this lesson. I just have already taught it to you. So I don't think there's any instructions. So please, at the top over here, put graph the function. And even though it says y equals, I'm going to show you a little something extra that your book has on page. I'm going to find it. Your book has it on page, what page is this? 290. And it's called function form. So where this y is, we replace it with function form. F of x equals x minus 5. This is the same thing as y. And for C, it would be f of x equals negative 2x. That's just a little extra. If that confuses you, don't worry about it. But what it means is it's a function of x. X is your variable, your independent variable. And this is a function of x. And so that's what it tells you, what the variable is in the equation. But this is the same thing as y. So I was just showing you that. We already know how to graph this. We pick out the m and the b. So the m is 1, the b is negative 5. And you graph this. 1, 2, 3, 4, 5. And the slope is 1, so it means up 1 over 1, up 1 over 1. All right. You connect them. Boom. Draw your arrows. Letter C, the m is negative 2. And that y-intercept, there's nothing out here. So that means the y-intercept is 0. We graph B, and then our slope is negative, which means it goes negative. So down 2 over 1, down 2 over 1. You connect those and draw your arrows. So that was simple. I know you know how to graph. All right, now let's go to the back. Here is some of our new part, okay? I'm first going to talk about, this is the new. Okay, there it is. It says, I'm looking for my mouse. Okay. Continuous versus discrete. So it applies to the domain. So we need to look at the x variable, the x-axis, the x variable. That's what we look at to determine if it's discrete or if it's continuous. So the difference between the two, if it's continuous, that means it could be any value, whole number or decimals and fractions, If it's discrete data, it's only whole numbers. Only whole numbers. Another difference between the two is when you graph them, you graph a line if it's continuous, and it could be any of those numbers, like on a number line, anything, you would graph essentially a number line. If it's discrete data, you graph dots. So for example, if we had an like the one we just did with oranges and apples, and we were graphing pounds of oranges and pounds of apples, we graphed a line because you can have half a pound. If we were over here and we were graphing like, what if we were graphing like actual number of apples at the grocery store? We were paying per apple. You're not going to go to the grocery store and buy half an apple. So you would actually graph only dots like this. So that is the difference between the graph is a solid line or you're graphing dots if it's discrete. So some other examples of discrete data would be if it ever said the number of people. Here are some examples that the book gave you. The number of glasses in a cupboard and the number of chocolate chips in a bag. So essentially, if you were to open a cabinet, you actually count like glasses in the cupboard and the number of chocolate chips. Yes, there might be like broken pieces, but essentially you're counting the whole chocolate chips. Continuous data would be the number of ounces in a glass because you could have half an ounce, or you could have 3/4 of an ounce. The weight. So anytime weight is a big one that's continuous because you can have half a pound or you can have 0.25, you can have a fourth of a pound. So if you can have decimals or fractions, it's going to be continuous. Again, we're only looking at the X. We're only looking at the domain. So the number of people is always going to be discrete. If you have to buy tickets for something, like the number of tickets to the movies, it's going to be discrete. If you have, an example would be length, like if you're measuring the length of something in inches or centimeters, that's going to be continuous because you can have a partial inch or a partial centimeter. Usually money is going, or time is going to be continuous because you can have half a minute, you can have half an hour, 3/4 of an hour. And so time is another one that's usually continuous. So let's do an example with this information. And I think this is our last one. Whoops, I went up too high. Okay, never mind. I'm trying to use my pen, but it's not working very well. I'm sorry. I don't know what I just did. Okay, here we go. I need to take a picture of this. Technology. I mean, really. Okay. Now, a store sells assorted nuts for $5.95 per pound. Now, again, I think I mentioned this in class, but just in case I didn't, I don't know where my mouse is. There it is. Per pound, that is our X. That's going to be your X variable. In this case, we might use a different variable, but per pound. So $5.95 per pound. That's your domain. Write a function equation to represent the total cost. So C for any number of pounds, P. So we'll use C and P. The total cost is going to be $5.95 per pound because it says per pound. So it means times pounds, number of pounds. Letter E, complete the function table below to find the total cost of 1 through 5 pounds. So our number of pounds and our total cost, 1, 2, 3, 4, 5. And then this, of course, where you would do your work, like $5.95 times 1, $5.95 times 2, $5.95 times 3. You get the hint. If you have your calculator, you can use the tools that you have. Type that in your y equals and look at the table. I already have the answers, so I'm just going to copy from my paper when I already did this lesson. $5.95, $11.90, $17.85, $23.80, and $29.75. So that's the total cost. Now, so that was part, right? So we did D and we did E. Now F, graph the function. Is the function continuous or discrete? And explain. So before we can just really graph it, we need to answer, is it continuous or discrete? So 1 pound is $5.95. Whoops. 2 pounds is $11.90, so it's a little bit more than 10. 3 is $17.80, so that's going to be in the middle. 4 is $23.80, so that's going to kind of be in the middle. And 5 is right before 30. Okay. So I've graphed my ordered pairs. Now, is it going to be a line or is it going to be dots? So we need to look at the domain. The domain is down here. This is the number of pounds purchased, the number of pounds, and the Y is the total cost, C, number of pounds purchased, P. So we need to look at the domain. Number of pounds. Can you have a partial? Can you have a fraction or a decimal of a pound? Can you only go and buy 1 pound, or could you buy 1.5, 2.5? And yes, you can have a partial. So that means this is continuous. Almost circled discrete. This is continuous. So that means our line is going to be a straight line. And when it says explain why it's continuous, you would say, because you can buy a fraction of a pound, or you could buy a partial pound, or you could say it doesn't have to be a whole number. But the reason it's continuous is because the domain can be a fraction or a decimal. It doesn't just have to be whole numbers. So that is a quick lesson, and we will practice more in class. I have to, oh, there it is. I was like, how do you get out of here?